So today I'll be talking about online multiplayer, subtitled The Building Blocks of MMOs. So you could take a picture of this QR code if you want the link to the slides. Hopefully in the near future I won't delete it. Probably won't. Yeah, don't worry too much. It'll be on the Game Dev Happy Hour YouTube channel. So my name is GJ. I'm a game developer at Nine Cats. My official title is Game Developer and Code Architect. Last time I gave a talk here and I think it was pretty long and very technical. So I hope for this talk it would be like a really balanced talk that everyone could have something to take home with. Whether you're a beginner in game development or a gamer or you've been a seasoned developer for a while, I hope there's something you can take out of it from today. So let's get started. If you've been in the game industry for a while, you might have heard about this kind of meme. So basically, first-time game developers, they want to make an MMO for their first game. So you can see it all the time in Reddit. Once in a while, someone's going to ask, hey, I'm making my first game. How do I make an MMO? And there's also many articles saying, don't make an MMO for your first game. So like, it's been around for a few years. But the question is, okay, I get it. I'm not going to make an MMO for my first game. I made several small games. I'm relatively experienced. Now what? How do I get started? What's so different between making single-player games and multiplayer games? And lastly, can I actually build an MMO by myself or as an indie? Is MMO just limited to AAA studios, or could I make one myself too? So that's where we're going for today. So basically, we're going to answer two questions. First, why is it so hard to make multiplayer games? And secondly, we'll talk about how to start developing multiplayer games anyways, even though it's hard. So, another disclaimer before we start though, take everything I say with a grain of salt. It depends. Whatever you read a book, go to a conference, listen to a talk, wherever you learn anything, always don't trust everything that person says. Don't trust anything I say. It depends. Every game is unique. But it is good to have a huge toolbox, but know which tool to use at the right time. And always remember, simplicity is much better than complexity. Don't use everything you know. Use what works. So first, let's begin with game design. It's not easy for single-player games. Game designers here, you get it. And it's not easier at all for multiplayer games. So the first thing I want to talk about in why multiplayer games are so hard to make, we can first go in from the game design perspective. Game balance, obviously. It's hard for single-player games already. When you got many people playing at the same time, especially PvP, when you're playing competitively, game balance is hard. Game economy, especially if you involve real money. Content, whether you want to pump out new content. Is it a live service multiplayer game, or is it like one time only? How do you cater new players and existing players who have played for years? Like, these are questions you might not need to ask yourself if you're developing a single-player game. But once you're in a multiplayer game, you have to start thinking about these questions. For MMOs specifically, how do you become a unique MMO? Especially when a lot of people do play MMOs growing up. For an MMO to shine right now, you have to have your unique selling point, right? So how do you be unique in this market? And how do you attract massive amounts of players? Like, you cannot have an MMO without massive people. So being unique also helps you to attract a massive amount of people. And once you attract them, how do you maintain this community to keep on playing for years to come? So that's a very difficult game design problem to tackle if you're developing MMOs or even multiplayer games. There's this term called critical mass, which is, according to this book, it is defined as until your game has an X amount of players, it will keep losing players because there aren't enough players to play in that game. It's really important not only to nail down your game design, as mentioned a while ago, but also your marketing and monetization. And how do you reach to this big group of people? And monetization, because multiplayer games are expensive. As a rule of thumb, according to a book I read called The Development and Deployment of Multiplayer Games, really good book. It says, as a rule of thumb, you should have at least a few hundred players at all times during the day. That's considered like a healthy ecosystem. Of course, it depends, but it's not easy to get like hundreds of players at any time during the day, 24 hours. So would you consider having bots within this pool? Like, I think Brawl Star has bots in them, but you don't really feel it because they have quite good AI, I think. So that's also a question, like, how intelligent are the bots? Like, are they explicitly bots, or they're pretending to be human bots? And that also added cost in development. So that's something to think about. Speaking of costs, let's talk about that. In the very early stage of your multiplayer game development, you have to think about cost because it's really important. It's already important for single players, even more so for multiplayer. So you have to ensure your per player monetization is more than your per player cost. So here are some numbers for reference. This is from Photon, very popular multiplayer framework for Unity. So CCU stands for concurrent users. You can see for 100, you got to pay 95. This is in US dollars, by the way. So that's like almost $1 per player at any given moment. That is paid per month. As it goes, you could get it cheaper, but there is a fixed cost. So if your game is free to play multiplayer, you would be paying that out of your own pocket every month. So you have to have some sort of monetization. That's just for reference. But this is not the entire cost of game development. This is just the multiplayer framework. So keep that in mind. And there's also like, this is another service called Hathora. This is the cost for a server. So let's say you have 100,000 matches per month. Seems like a lot, but actually it's just 2 matches per minute. 2 matches per minute, it could go up to 1,400 US dollars per month. So that's like 10K Hong Kong. So if you have 2 matches per minute during the entire month, you have to be paying $10,000 in Hong Kong dollars per month just for server costs. So monetization is something you have to think really, really early on if you're developing a multiplayer game. Here are some other numbers for reference. This one is also pretty similar to our number a while ago. A while ago is 100,000. Here is 1,200 $200 a month for game server cost. That's US dollars also. This number is in 2017, so it's much higher right now. Database also has costs, network traffic, DDoS protection, so you have to protect yourselves against hackers, and support costs. Support costs is something you also have to think about, not just the technical side or marketing. The customer support is also quite important. Like imagine from the book, it says if you have 100,000 players, you have to expect around 10,000 emails a day, like just complaints or technical issues or what. And you need people to reply to these emails. So that's manpower. So just keep that in mind. Other than costs, you also have to think about your game's lifespan. So typically there's 2 kinds of lifespans. One is limited and one is undefined. So the name says it. Limited is like, oh, I expect my multiplayer game to really just go on for 2 years, and that's cool. Some games like League of Legends, you get it for like 10 plus years. So those are we call undefined games. It's important to nail it early in your game design before you ever start developing your game, because it affects 2 things. It affects your game design and it affects the technical aspects. First, game design is simple. It's like, do you have to keep on pushing out new player content? If it's undefined, you have to be constantly attracting your players, keeping that community there, right? And do you have to constantly game balance your game? Do you have to apply buffs or nerfs to the different characters in the game? For technical decisions, whether you should use Unity or not, like it's a third-party engine. What if Unity, the company, doesn't do Unity anymore? What happens to your game? That's why there's this notion that only AAA studios can make big games, because in some sense, it's kind of right, because only they have the budget to make custom game engines. But there are indie games that do use like third-party engines like Unity, so don't be disheartened. That's something to think about though. Other than that, during your game design phase of the game, you also have to really be clear about how entities interact with each other. Entities include both game entities like NPCs, your players, shops, and non-game entities such as the payment systems, the cashiers. So you have to really have a big picture view of how players interact within the game and outside of the game. Only then can game designers nicely plan out their content and technical people could do their technical stuff. From the book, there are some examples of what is an entity interaction diagram. For example, social farming games, you have players which interacts with the farm, interacts with their friends, interacts with Facebook, social media, interacts with their credit cards. Like, it's good to have a bird's eye view of these kinds of things when you're developing your game. Casino types of games, you have stock exchanges. So there's this really nice line that this book I've read mentioned. Basically, if you know how to write multiplayer games, you could write stock exchanges. So they're basically the same thing. Stock exchange is basically a simpler version of a multiplayer game. These are some entities that might be needed within it. MMOs, they're basically the same. Players, payment systems, game entities. Have it thought out before you start making your game. So in this book, it's written by this guy who's really, really experienced in making multiplayer games. So he came up with a list of requirements that your GDD has to include. GDD stands for Game Design Document. I'm not going to really go through every single one of them, but there are a few that I have not really mentioned yet. For example, timing requirements. Not all multiplayer games are FPS shooter games, right? Some multiplayer games are online poker. Some are intense, real-time royales type of games. So they have different timing requirements. Like if you're playing online poker, it's okay for a little lag, right? But for if you're playing something like Overwatch, you cannot have lag. Like that's something game designers have to tell the programmers early on, because that's a very important part of the technical aspects of making a multiplayer game. First download time is also important. Do players have the patience of downloading your game? Does your game run on mobile data, or it's okay on Wi-Fi? That's also an important thing about. Internationalization, that's something to think about as early as you can, because translating is a pain in the ass. Also, server and client update requirements. Whether, sometimes when you play a game and it says server maintenance mode, it's not really in maintenance, but they're just basically forcing you to update your game. You have to specify early whether you're okay with that, especially if you're a big company. Like, it's something to think about because it does affect user experience, right? What if you have to update your server? Do you put out that server maintenance mode and update it? Or do you have the technical requirements that, the server has to update while existing players are playing on my old version, then migrate them to the new version? Like, you have to have this requirement early on. Yeah, highly recommend making a GDD before making your game, because it affects a lot of how you actually make the game. But make it as detailed as possible as well. Although there's so many things to think about even before you start making the game. Like, it's kind of contradicting, but also don't worry too much about it. You don't have to be perfect, because just like games are an iterative process, the game design is also an iterative process. It's okay to be wrong. You're supposed to be wrong. At the end of the day, you will find a game that is much more fun. But plan ahead as much as you can so that you'll be prepared. My suggestion, if you're starting out, is especially if you're not sure if the game is even fun yet, right? Like, this whole time I've been talking about game design difficulties, but there's nothing about the actual gameplay. So what if my game is not fun? Do I spend all this time making it? I'd suggest first make a single player version, ask people to play it, see if it's really fun first, or even make a local co-op version. You would also spot out some technical difficulties that you may face if you actually start making a game. And maybe, just maybe, you may find out that local co-op is actually just good enough. You don't have to make an online mode. Yeah. So that's about the game design difficulties. And now we will step into technical difficulties. The book says if you can make a multiplayer game, you can make a stock exchange. So the difficulties of a multiplayer game is more than making a stock exchange. So for local co-op games, let's say you have two controllers, you're basically playing a single game together, right? The difference between local co-op and online is that you're playing two games at the same time. And there is inherent network lag between any two. We call them systems. The term is called distributed systems. Every single online multiplayer game inherently is a distributed system. Stock exchanges are distributed systems, multiplayer games as well. So other than network lag, which everyone knows about, since we're playing two different games at the same time, there's the problem of state synchronization. How do you synchronize your game with my game such that we are seeing the same thing, even though there's lag? How do we prevent cheating? There's also back-end complexity. I'll go and touch a little bit on it. Like, there's, other than the game itself, you also have to think about pricing. You have to think about payments. You have to think about connections to your social media, Facebook. And also the development flow is much more difficult for multiplayer games than single-player games. Especially at work, like we're making 9cat, it's a multiplayer game. No advertisement intended. But I mean, when I'm developing the game, I have to have like two instances of Unity at the same time. I have to play like two players at the same time just to look for bugs. And even so, there's always going to be some bug that I've never tested and somebody's going to report it. And it's going to be so hard for me to replicate because I'm playing two players at the same time in a single computer. Yeah, it's tough. So development flow, it's something you have to think about when you're making multiplayer games. It's especially difficult, especially if you're a solo developer. So have that in mind. Yeah. I hope I didn't scare you off because multiplayer games are tough. That's why a lot of people don't want first-timers to make MMOs for their first games. But let's say, okay, I get it, I know it. How do I start anyways? Because I really want to make this multiplayer game. And I appreciate it because there are some aspects of multiplayer games that you cannot get from single-player games. I personally love single-player games. I play single-player games a lot. But I also have to admit that having another player with you in the same game is really a much more different feeling than single-player games. So how do you start anyways, right? I'd say there's two steps in starting multiplayer games. First, you need to know what you need to make multiplayer games. And second is choose tools based on what you need. Other than game design things, We'll now talk about technical things that you need to know. First, you need to know what kind of network topology you're using. Wow, what a huge word. Basically, network topology is a discussion of who owns the state. So a while ago, we talked about how multiplayer games are distributed systems, right? So there are different games happening at the same time. So the question is, who owns the state, right? Who is the source of truth? Like, am I looking at your state and doing it, or we're doing our own thing at the same time? But if we're doing our own thing at the same time, then how do we prevent cheating? So that's the whole discussion of what is network topology. So there are basically unlimited amount of topologies, but in general there are three. The first one is called authoritative clients. So normally if you're new to game development, there are servers and there are clients. Authoritative clients means the clients are the one who are in authority of their own state. As you can see here, state is transferred to the other one. So I jump, and then that sends the state over here. Then he knows to jump because of that network lag. He owns the state of this guy, and he owns the state of this guy, and he tells that person, hey, I'm now at this position, this position, this position. So that is authoritative clients. This is like the most, we call them naive implementation of multiplayer. It's not without its pros. It's simple to do. I just basically tell you where I am. You show I am at that position. And it's cheap to do. There's no server involved. I just tell you where I am. The cons is you can really see that there's lag. When he jumps, it takes some time for me to see that he jumped. And it's not synchronized. And also, hacks. Authoritative clients are basically powerless against hacks because you have to trust that what they're telling you is true. I don't know if you have seen these kind of hacks before in multiplayer games, but that's basically why it's happening. It's because they allow the client to be the authority, their own state. So it's okay though for co-op games. Like sometimes it's fun to see people hack. So it really depends on your game. You don't have to prevent cheating, but it's good to do so. The next type of network topology is called deterministic lockstep. What a mouthful. So deterministic means that no matter how many times I run a algorithm or a sequence, it always ends at the same result. So basically everyone is running the same game. If I'm given the same inputs, I would have the same output. Because I receive two jump inputs, so I would know to give the same output. So that's how we sort of solve the state indifference between systems. It only works if you both have the same initial state, of course. So basically in here, the difference is that we are syncing the inputs, the jump press, rather than syncing the state. Like in the previous one, I'm telling you my position where I was at. But in here, I'm not telling you my position. I'm telling you that I jumped. And you know what to do with that information. You show that I jumped from this position to up there and back down there. It's much more different. You can already tell that because I'm just sending input rather than state, it prevents a lot of hacks. Like I cannot just tell you I'm in the sky because there's no input that can force me to like float in the air. So that prevents a lot of possible game hacks. And it's a really popular network topology, honestly, in many games. But it's not without its cons. For example, information hacks. Let's say you're playing League of Legends, right? Huge map. But when someone is hiding in the grass, you can't see them, right? If you're using a deterministic lockstep, although you can't see them, the computer knows that player is there because the whole game is in your machine. I don't know if that makes sense. Like, in order for deterministic games to work, you have to know the positions of every single player, of every single object. Then I could have the same output given an input. That means everyone has the same information. So it's possible to make hacks like I could see people in the grass. And also fog of war, or see-through wall hacks. These are basically done because the computer itself knows that that player is there. So it's easy to hack through that. Another problem would be desynchronization. Like what if for a split second I missed your input? Like it happens with networking, right? Then our game state will be totally different. And because it's no longer deterministic, everything goes into chaos. We cannot ever merge back into the same state. And it's also really hard to do reconnects. Like I think League of Legends does it pretty well. Like when you disconnect from a game for some reason and you can go back into the game, right? If you're a deterministic game, it's not that easy to suddenly go in the middle of a game because it all relies on everyone having the same initial state. Giving the inputs, then your outputs are played. So if you're in the middle, you don't know the initial state. So there's no way you can know what's happening with the game right now. But it's very suitable for small scale games. Like let's say you're doing Brawl Star, the 3v3, get the gems in the middle kind of game. Everyone can see everyone anyway. There's no fear of information hacks. You cannot rejoin in the middle of a match. Sure, do deterministic. It's pretty good. It's cheaper because it doesn't need to be a server. You're just sending inputs to each other. So it's not bad. It's just that know why some people don't. And lastly, we have authoritative servers. This is probably the most well-known network topology. We send our information to the server, and then the server sends it down to us. Here it says state, but you could also send input. It's the same thing. So how it works is I press jump, I send a signal to the server, and the server allows me to jump and tells me, okay, jump, and then I would jump. This works for most games, but it's also expensive because you have a server. But although it's called authoritative servers, client-host games also count in this category. So like I think Deep Rock is a client-host game. So I open a room, I'm the host, and my teammates join this room. They're my clients, and I essentially own this state. And they're sending their inputs and states to me, and I'm telling them, hey, okay, cool, you could jump, you could run. That's authoritative server. And there's a lot of pros, of course. Whenever you own the server, you can prevent a lot of hacks. You could ban people. There's also the interest management. So interest management, what does it mean? You know, previously in deterministic LoStep, every single player has to know the entire state of the game for it to work. For this kind of topology, you don't have to know the entire game. The server could only tell you what is near you, and then you just have to render what is near you. Or the player could only tell you information about your own team, so you cannot do any hacks to know about where are the other team. So that's what we call interest management. I don't know why technical people like making really long words, but they don't really make sense. But yeah, that's interest management. Lastly, interest management also links to scalability. So if you are planning to make an MMO, most of them are authoritative server topology. It's scalable because the client, the players, they do not need to know the entire world state. They just need to know what are near them. And as long as you have a powerful server, that works. So you can have a lot of players. Of course, there are a lot of cons. If you're playing client host without a server, the host has the ultimate advantage, and the host can do whatever hacks he wants and no one can stop him. And there's no lag for the host because it's just playing with myself. But with them, they have to send their state to me, and I tell them, okay, you could jump, and then there's lag. And that's kind of unfair. But it's okay for co-op games, but it's not okay for PvP. And also, money. If you don't want to have this kind of unfair advantage, you have to have a server, and servers are expensive. As we mentioned a while ago, like that's like 100,000, 10,000. You have to pay like 10,000 Hong Kong dollars a month, something like that. So like it's like really expensive. So that's something to think about. Yeah, so that's network topology. And now let's talk about state synchronization. So we have already talked about how multiplayer games are distributed systems, right? Everyone has their own state. And we've discussed who owns the state, right? But my state is still different from the one who owns it. How do I synchronize my state with their state? Or what if I'm cheating? Is there a way to force me back into the correct state? So that's what state synchronization is all about. But there's an inherent constraint in multiplayer games, which is networking bandwidth. There's only so many things you could pass at the same time through the network. Like there's an unlimited amount of things, and there's the time it takes to send anything through a network. To me, basically, this is the heart of multiplayer complexity, at least technically. Most of the complexities of developing multiplayer games comes from state synchronizations. When you're talking about state synchronizations, you can often divide all the possible states you can have into like 3 categories. One, you have the server state. Second, you have the network state, or some books call it the publishable state. The third one, you have client state. So basically, a while ago I keep mentioning how the client sends an input to the server, and the server allows you to jump, right? So what the client sees, the animations, the meshes, hears the sound effects, sees the particle effects, the VFX. We call that client state. Like server does not need to have any single knowledge about the animation or whatsoever. So that's client state. And then client sends like their input to the server. So the input is basically like jump equals true. We call that a network state. Pack it as small as possible to send it to the server. And the server, they would have a state such as like the velocity or the hitbox of the player or the position of the player. We call that server state. So let's say there's a wall in front of you, right? And then the client was like, hey, I want to move forward. So it gives a forward instruction to the server. And the server has the hitboxes of all the walls and the players. And then the server determines, hey, you got a wall in front of you. You can't move. Then the server gives back, let's say, the position of the player, and the player doesn't move. So basically, when we're talking about state, that's how we divide and think about state. Of course, because of networking issues, the client state is never synchronized with the server state. And you have so many players at the same time with a single server, and every single player has different networking speeds to the server. Everyone's state is at different time. But when I press jump, players expect it to immediately jump. I can't wait for the state to come back from the server. So let's say like if we have like 100 ping, 300 ping, that's 300 milliseconds. So when you press jump, you have to wait 0.3 seconds for it to jump. That feels really bad. So there's this thing called client-side prediction, which helps solve this issue. Know that not all games need prediction. If you're making poker, you don't need prediction. But if you're making Overwatch, you need prediction. So up here is the client. Here's the server. You can see here the client moves first, then the server moves afterwards. But even though the client moves first, the client presses the button, the game is programmed in a way to show you immediate feedback. So you see this yellow dot here, that's what the client sees. And the purple dot behind it is what it receives from the server. It's always lagging behind the server and lagging behind the client. So without prediction, if I don't move first and only wait for the server to send the state back, the client will always be moving in that purple dot. It'll be really laggy and really slow. So we have to do client-side prediction. So other than movement, there's many other things that has client-side prediction, but at least you know whether you need it or not. Client-side prediction, other than my own input to my stuff, what about other people, right? I'm already living in the future, in a time that is in front of the server. But other people are too. And what happens when I receive their inputs? How do I render them correctly? So client-side prediction also has to do with predicting other people's things. So if I move forward and someone else moves forward too, that person has to send their input back to the server. But by the time I receive their input, I'm already over there. So how do I render that other player? Basically, client-side prediction is also called rollback. You might have heard about this term. Street Fighter and those kind of games use this. So basically, when I receive the input when I'm already there, I time travel all the way back in time to where that input started. Then I recalculate where he should be and where I should be and show the correct state. So basically, every single FPS game you're playing is basically time traveling every single second back in time to replay what other people are doing 60 times a second. And that's kind of amazing to think about. So basically, if network is slow, it'll look as if it's snapping back. Of course, you can make it fancy and make it glide to that area, that position. But basically, that's what happens every single frame. You're re-simulating what everyone else does, and that's what gives a smooth multiplayer experience. Again, not all games need rollback code, but it's good to know. Other than client-side prediction, another thing that is important to know whether you need it or not is called lag compensation. I'm already talking about how we are living in the future in front of the server. So like I'm moving, but I send my state to the server and the server lags behind. And if you think about it, if a server is already lagging behind me, when I receive other people's positions, they're lagging even further behind. So I am forever aiming at the player in the past. But he's not actually there. He's actually already here. So what happens is I will never be able to shoot at him if I'm always aiming at the past. Oh, that's so meta. So we have lag prediction. So what is lag prediction? Basically, at the moment that I fire, the server rewinds in time to see exactly how I see the world, and at that split second trusts that I am telling the truth, that I actually shot that guy. And then the server will then allow it and say, okay, you shot him in the head. Then you die. So what's bad about this? There's a split second where the server trusts the client, and that split second is enough for hacks. Number two, it gives an unfair advantage to players shooting it. And people who receive the shot, they might have thought they've already hidden behind a wall or hidden behind an obstacle. But then they find out suddenly there's a headshot out of nowhere. I don't know if you guys experienced this before, but that's why. Maybe for that split second, you thought you already hid. But because he's seeing your past self that hasn't hid yet, so he gave you a headshot, and the server trusts him and not you. So that's lag compensation. But although it does allow some sort of cheating or some sort of unfair advantage, at the end of the day, happy players are more important than cheating sometimes. I mean, if they have an unfair advantage, that also means you have an unfair advantage too when you're shooting them. So everyone's unfair anyway, so it's basically fair. Yeah, so there's no more cons. Next. Okay, other than lag compensation and client-side prediction, there's also a bunch of stuff that you need to know, whether you need or not when you're making a game. I'll just go through these really quickly. I don't want to bore you guys too much with technical details. One is authentication. Do you log in with Facebook or Google or Apple or not, or is it password authenticated? If it's password, what do you do if your player forgets their password? Do you email it back to them? What if they still don't remember their password? Do you have customer support for them? Like, you have to think about that. Database needs, you also need to think about that. Lobbies. If you're playing PUBG, you have to wait until there's like 100 players, right? So there's a lobby that has to exist to hold you guys. So that's not really part of the game, but you have to think about that, right? Matchmaking also. So like when you're playing a ranked game in Brawl Star, you just play quick match. How do you match people from all around the world who are waiting? That's something that you have to think about. It's a back-end kind of thing. Server orchestration. Now that's something that's tough. You remember that green server on the top, right? Let's say I'm in a lobby. I have found my match, right? The matchmaking service has gave me a match already. Okay, we're gonna start a game. Then that service sends a instruction to the server orchestration service to basically give you a server to play in. That's what server orchestration does. A match is made, give me a server. My match is done, give the server back to you. And there's also guild systems. That's something you need to think about if you want guilds in your game. So now you know how difficult it is to make multiplayer games. So how do you choose what? What a mouthful. Rule of thumb, you can't really go wrong with things that are popular. Like, there's a reason why Unity is being widely used, even though Unity may not be the best company in the world. It's popular, it has a huge community. Whenever you need help, there's tutorials online, there's people you could ask. We all hope that other game engines could rise up to something like that kind of size, but it's kind of hard to beat. But even though we would always choose popular tools and engines, don't sleep on doing stuff yourself. Give some confidence in yourself sometimes, because sometimes it's not as hard as you think. But speaking of DIY, there's always the age-old question of whether I should use a game engine, whether I should use a library, whether I should use this or that software as a service, or should I do it myself? There's a lot of things you have to consider. I mentioned before, is your game limited or undefined? But more than that, it's not really an A or B question. You don't have to DIY everything. You don't have to use services for everything. Like, some stuff you could use the service, like you could use Unity as your game engine, but you could write your own networking code. I don't really suggest it, but you could. Or you could use all services, right? You can use multiplayer networking services and your Unity game engines and matchmaking services, or you could write your own matchmaking. The rule of thumb is really DIY your added value. There's always this unique added value to your game that makes people want to play it, something that's different from everyone else. The suggestion is write that yourself. Write that's a really special thing, unique thing yourself, because probably those services haven't even thought about it because you're the one that thought about it. So write it yourself. There are a lot of options. Unity, there's a bunch of networking services, but for Godot and Unreal, they're actually built in. So that's something to think about. But for Godot, the built-in multiplayer is quite basic, I would say. So there's a lot of open source add-ons you can think about. For lobbies, matchmaking, and server orchestrations, there are services. The typical Amazon, Microsoft, Google, they have these services. You could also write your own. So just letting you know about these. My tip would be keep it simple. Think about costs early. Always test your game in multiplayer in advance, and always test on your target device, especially if you're making a mobile multiplayer game. Sometimes you thought the game is cool, it runs, it works, but apparently it crashes all the time on your mobile phone. Especially if you're making client-host games and you're the host orchestrating everyone's state, and apparently someone is using an iPhone 8. Always test it early, and don't get too attached to what you're using. Be okay to iterate, be okay to do stuff over. Sometimes the extra control from doing stuff yourself is worth it. So let me answer the question. Can you make an MMO? You can. It's hard. It's just really hard. There's many things to consider. But if you think you could do it, if you really want to make it, like, just do it. That's my talk.